Wait, how did it fall? Maybe because I've turned it to water. I need the basic chemicals and you don't need my finish. Okay, now I am right. No, I'm not gonna do now nuclear fusion. So guys, today I was learning about the periodic table. So let us learn together, I thought. So let's start. I'm gonna give a few rules and some explanations to let you know how does the periodic table work. So let's start. The first rule is that you have to count the shelves by the chemicals on the rows of the periodic table. Yeah, I'm showing you. I have marked it. Firstly, we get 2, which makes sense because hydrogen and helium. Then we get 1, 2, 3, 4, 5, 6, 7, 8. As you can see in this atom, you know that there is first the 2 and then 1, 2, 3, 4, 5, 6, 7, 8. So it matches. Now there are 2 8s. After that you'll get here where we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Wait, I have done a miscounting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, there are 18. I did a miscounting, that was funny. And this goes overall and perfect like that. So I am gonna do only the rules of this and as we are talking about rows and groups, rows are what move horizontally and vertically are groups. Seems like beryllium is in the group of magnesium, like that, and beryllium is in the row of lithium. That's also like that. So to find out the location, you need to also know its surrounding elements. This is also I just told this about. Okay, let's call other. We will understand the other rules next after we get in. So let's start. Firstly, let's see this, and I'm going to tell a lot of them by seeing because this is almost like impossible to just see alone. Okay, let's just see. I'm gonna tell about the most I'm saying. Okay, and there are atomic numbers so that you understand. Each row, as you go, you get a lot of atomic numbers, you know. Now let's start, finally. Firstly, we get at hydrogen. Maybe you are familiar with hydrogen. H. Right? Hydro means water. But why? Why is this watergen? Okay, you must have been heard this if you are above, let's say you are above class 2 or 3, maybe like that. So you might know that the chemical formula of water is H2. I have done it a little. H2O. So you see that there's one H that represent hydrogen. Never mind about my handwriting becoming more capitalized. All these days I do in math capital letter writing, so you know. And maybe I have done a mistake of hydrogen. Maybe a spelling mistake. Okay, whatever, let's just say. So this hydrogen maybe has to do with the gen name only, but only if it doesn't make a water molecule. And without hydrogen, many of your daily things are gonna be dead because hydrogen is in most of them. Why? Let us understand first. Hydrogen was the first chemical to appear on the whole universe, and slowly they turn into helium, then lithium. That's how it patterns happens. And most of them, some of them are artificially made. We don't count them. So let's go in next. Helium. Now this one is a little too complicated. Let's say this. Helium is a noble gas. What is a noble gas? As I told you earlier, a noble gas is, now see, you became stable when you became on the row's last end. Now you might not understand it what I am saying. I mean, helium is the atomic number 2, so it has 2 electrons. So it became stable and is ready for a new shell, but that shell has no electrons. So how could it bond? That's noble gases. So it's a lot fun to do this thing. So we have a lot more things like helium is a lot complicated. It is the second. Okay, this is the second oldest chemical. Okay, I have not more time, and explaining all this quickly will be the time. So I quickly say this all and say kind of important points. Okay. Let's go to lithium. Lithium is the third, and then it has 3 atoms in it. That's it. Let's go to beryllium. We have 4. It is found when star 7 supernova. Wow. Maybe this is a lot funny because I have a star and then I broke like this. Let's go at boron, then nothing boron. But I could have sent about the boron. Just remember when I go here, then just remember about this, okay? Next, carbon. Now I have to explain here. I am saying that there are 2 types of things. You must have heard about metals, which I write M, and non-metals, which are not metals. Now let's say this is not a metal, this is a metal, but this is not a metal, and so on. Like this is not a metal, more. Like this, you understand carbon is a non-metal, and all the things that I have said for now is non-metals. Understand now? And non-metals and metals difference are a lot. Like as you see, metals lose their electrons to become stable and go to the end, not the end, but the beginning, and their closest I mean, I have to explain this to you. Let's say calcium is a metal. So which is the most closest noble gas of it? Yes, it's argon. We are going to talk it about later, but let's say this is argon. So it has to lose 2 electrons. The reason why they only lose electrons are because every molecule wants they have to get stable by less energy so that they become quickly stable. More energy means sometimes corruption. So all these tables, all parts are not. Now non-metals are different. They take electrons to become stable. Like carbon. Okay, let's understand. Remember the thing I told earlier? Yeah, I told you earlier a lot. Wait, why is it here Ca? There should be another thing. Let's say O2. CO2. I just made one up. So now see that a carbon atom needs to lose around, no, not lose, to gain 2, 3, 4 electrons to become stable. Anything's up, really, and that's why these are all non-metals. Next we got nitrogen. It's a crucial part of agriculture. Next we get oxygen that you are breathing right through, and that gas that I come through is also oxygen. Like this, that was oxygen, you remember. Okay, next we go to fluorine. Yeah, you did. It's crucial, or otherwise your teeth are gonna be just fold and never ever grow back. Next, neon. Wow, the second noble gas. Now, how this noble gas works? This time you get 3 things. Let's just say like this. So firstly you get 2 electrons here. So here are 2 electrons, and you get here 2 electrons. That means you became stable, but you have 10 more things to do. So you need a lot more things. So you take more things, around 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So you understand. But another shell is left. What are you gonna do with that? You can bond easy. All these things except for this is completely noble gas. I just say that. Okay, next up we get to the last 8 shelf. Then we get to sodium. Wow, you need salt, but a world without sodium won't have any salt. Or basically table salt or sodium chloride. As you see, Na means sodium. Okay, let's go. Wait, is Na related to something that says no salt? Let's go next. We get magnesium. No important in this word, but you need magnesium for you. Let's go next. Aluminium. You did this, of course. All your electricity, everything is almost made up of aluminium and iron, which I'm going to talk about next. Okay. So aluminium is also recording this video right here. Next we go to silicon. Nothing more than this. Just you won't get glass. Want some glass? Then you can't. It's an expensive product, but it harms your environment. Okay, this is not the time of that thing. So let's go next. Phosphorus. I don't recommend things about phosphorus because it's not that important, unless you know that it's important a lot, but not that much. Next we go to sulfur. Wait, who wants rotten egg smells? That's exactly what you get in sulfur. And want to get to a volcano, you will find also sulfur dioxide. Let me just do like this so that I can cover what I'm saying. Next we go to chlorine. Cleaning pools is used by chlorine, so you can't go to a pool if you don't have any chlorine. Star noble gas. Trivia. Let's go like this. Now I need to explain this a little more. So firstly we get 2. Then we get what? 2, 3, 4, 5, 6, 7, 8. Then we get 1, 2, 3, 4, 5, 6, 7, 8. Now, this is an atom of argon. Okay, the first 80. Crack it, chill. We get to potassium. Oh, remember I told you about potassium and calcium earlier? And this is the last, or maybe even dot or dot metal. I'm not sure, but I say it might be because, okay, let's say, oh, it is a metal because, of course, it has to be. It has to lose one, then it becomes the atomic number of argon. So you understand. Nothing more than that. Then calcium. Calcium is gonna be, let's say, a word without calcium will let you like this. Because your bones are made up of calcium. Remember that what I have said to that your mom said in your childhood, without drinking milk you won't grow your bones, but not that much because bones can fuse most of calciums together. They just took small parts, so that's not that useful, but it will if on years your bones won't exist because that happens. Okay, this not bad scenario. Scandium, maybe scandium, let's check. Yeah, it's scandium. Is something related to Scandinavia? I'm trying to pronounce their things are like closely related, but where is Via? This is our second metal, or no, third metal, so we are going to talk about it a little more things. It isn't that useful. Titanium is a lot useful. It's the atomic number 22, and we have to learn something new about this. Okay, got we can't. I got a fractured bone. Okay, I'm alright now because titanium is made artificial joints. You guys know this? Yeah, a lot. Then vanadium. Oh, here we go. Remember I told you about boron earlier? Now it comes handy. Vanadium is atomic number 23. So I make a vanadium molecule. So firstly it's 2. As you know, hydrogen, helium. Then you get 1, 2, 3, 4, 5, 6, 7, 8. Then you get 8 here. And then you get 8 again. And then you have to get 18 to get there. So you need 30 more electrons. Who wants this? You have to take all the energies in the universe to produce that. Actually, I must be joking, but but I got a little more aggressive because how can they get there? All the way to Krypton. Okay, we are gonna talk it later. But the thing is, it's a metal, so I don't have to worry. I have to just take out 1, 2, 3, 4, and 5 to do that. Still a lot, I know, but compared to what you need to do in there it's small, kind of small. But basically, you need to not even count like by making a periodic table. You can just use these electrons and take your outer shell's electrons and then minus it. So it has to minus 5 to bond. So it has to bond with boron, easy. Because if 5 is getting there, it will go to 10 electrons and then it will be going. I am not sure if it's, but it's ionic, but I know. Ionic. But it makes no sense because, okay, scientific sense, but it has no compounds useful to you. So I kind of say, next. We get to chromium. Okay, chromium is a lot useful to group. Now chromium, nothing. Then magnesium, then ferrium, iron, and a lot useful. Then cobalt, then nickel, cobalt, iron, nickel, copper is a little more less magnetic, but it's still magnetic a little. Then we get zinc, then gallium, right? Yeah, gallium. Something to do with gallium. Let me think about anybody took in some a gallon of some gallium. It will be some tongue twister maybe. So nobody will even ask. Okay, nobody will even try to get gallium because okay, whatever. Germanium. Just Germany has to do with something with germanium. Let's say germanium is found on Germany. Okay, in the same bag as the gallium, germanium. And what to do with Germany? Maybe you have seen my World War II video and maybe saying those are secret weapons. Just kidding. Let's go next. What is this? I forgot. Oh, yeah, arsenic. Arsenic is the atomic number 33 and that's it. Selenium, atomic number 34. That's it. Bromine, yeah, it's a halogen. So we could say if hydrogen reacts with bromine, it is gonna get to krypton already. So it becomes acid. Every single halogen that is from this row except for this, you know what I'm saying. You know what I'm saying. Becomes an acid if they react with hydrogen. That's why you get hydrochloric acid. Yes, you have acids inside your body. All those amino acids, hydrochloric acids, what are they? Aren't they acids? Let's go to krypton now. Okay, you know what? This is gonna take a long time to explain, so let's go down and ignore all the rest of noble gases. Okay. As down as you get to the group, you get less and less uses of things. So we are gonna skip a lot of these, but let's just say we won't skip. So we have to see all this row except for some of these parts of these, because I have only seen around 36 or 40 like that. I have seen that much. I have just seen that much. So we have rubidium. It's a metal, as you know. Everything in this shelf except for hydrogen is metal. Why? Because they're closest to the atomic number that it makes it stable. Okay, next go. Again, strontium is same. Deuterium is the same. I really hate this thing, zirconium. It took a lot of time to pronounce it at the first place, but now I know how to pronounce it. Niobium. Wow! It has to do something with neon. Party lights. Oh, I forgot to tell you that neon is used at party lights. Sorry, party lighters. You can't have neon without neon any party lights because they don't have anything. Let's go next. Okay. Molybdenum. 42 atomic number. Technetium, or at least what I say, technetium or anything else would happen in this. But at least what I say is technetium, but technetium actually. Ruthenium, atomic number 44. Rhodium, atomic number 45. 46. Palladium. It has to do something with agriculture, right? 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 No, it's a lot in the southern shell, so it can be used for agriculture. It has to be a lot in the north so that it becomes an agricultural product. Next we have, wait, where are we? Oh, palladium. Silver. Want some silver to eat? Silver food. Oh, wait. What silver food? Silver metal. Wow. Do you want to spend money on it? Okay, this is the third most expensive. I thought the second most expensive, but now I know that it's the third. And the most expensive corner is found at the leaks of metals in transition metals part, and this is the most expensive corners, and this contains this part. Wait, oh, I forgot about this. These parts are the most expensive corners. Right, it says in the leak of transition metals. I was just joking. Yeah, this is the most three of the most expensive metals. So I just made a leak of transition metals, as these are transition metals, and makes perfect sense. Yeah, not until you see this thing in the border, so you might not get from here. Sorry, Bismuth, you can't get there because you will be poisoned. Wait, you yourself has some poisoning reports. Okay, let's go next. We will ignore that part. We go to, what is this? CD. We want to party with CD. Okay, party lighters. We thought this you might also not get with CDs, but not. No. I was just kidding. It's cadmium. Let's just go. Is it Cadbury, a famous brand that I eat every day? A famous chocolate producer. India? Wait, it's right inside of germanium. What's the difference? They were rivals in World War II. Why? What? Okay, let's go to just like that. Ignore that part. Tin. SN. Let's go tin. We have some tins that will take some tins. We have some tins that will take some chemical tins. Let's say that. Tin is a metal used in everyday objects, and don't just think that tin are called tins because they are made up of tin. No, that is not a joke. Sometimes it is made up of tin, but sometimes not. This is also happens. Tins, and then we get to where were we? Antimony. We have some monies that are anti to monies. Okay, let's go next. Hurry up, we need to do it. What is this? A tellurium. Iodine. Yeah, it's a lot useful. Let's go to xenon. Okay, I told you that ignore the rest of the noble gases. Cesium and then barium. They have some babies that we could eat, but they are just metallic. Okay, let's go next. At Happy Now, I have told another joke. Now, before I go next, I tell you something, that there are some metals that are in the south, because just to do them fastly, in the quickly move and don't make it more long. It will be hard for scientists, right? So let's go in first at this, then in this. Okay. Nobody wants to first see. Wait, let's go. This is lanthanum. This is Syria. This is CO2, neodymium, promethium, samarium, European Union. gadolinium, terbium, dysprosium, holmium, erbium, thulium, yttrium, deuterium. All in one week. Actinium, we act to produce that thing. Then thorium, then platinum, and then uranium. These two are hard for you if you have seen the minerals video. Then neptunium, plutonium, americium, curium, beryllium, californium, insanium, fermium, maldivium, nobelium, then curium. These are some that are named after famous scientists or countries like that. Next, we have hafnium, tantalum, tungsten. Fun fact about tungsten, it has the symbol W. Then we have rhenium, osmium, iridium, platinum. Wow, we want to sell platinum, it will be a lot. And this is the corners and the most expensive. Then gold, another second most expensive. Let's go next. Mercury, that's why, because you will get mercury poisoning. Next, you go to, what is this? Wait, thallium, then lead, Pb, lead. This is radioactive. Bismuth, polonium, this is also a lot radioactive. At this time, this is the most rarest element of the universe. Next, we go to radon. Let's ignore that part. Francium, that evaporates immediately after it's created, and radium, radioactive from its name. And then let us go down. We have to not go down because we have talked about it earlier. Rutherfordium, rubidium, seaborgium, borium, haesium, metrinium, domitium, rangotium, copernicium, sinoium, flavarium, moscovium, livermorium, tennessine, or Tennessee. It's a state of America, right? Tennessine or Tennessee. What I don't know what to spell. Organism. The fun fact about the periodic table in the last part. Its corner is not this. The corner real is this. So this is it for this video.